All right, let's get started for the day. Reminder that we have 2 assignments that are due tomorrow. Both the sorts and the recursion assignments are due tomorrow. Yesterday was last night, the deadline for if you wanted guaranteed feedback by the exam. So graders going to be working on those that were submitted, and tomorrow's the last day to get them in. Thursday, we're going to review for an exam that will be on Friday. The study guide is posted. It goes through conceptually, some conceptual stack-based questions. I'm not going to have you implement any code for a stack, but you will need to know what they are, what they're used for, some other stuff that we'll cover today. So we fully implemented our array list based stack by the end of last class. Did anyone have any questions about this implementation? All right, so we're going to go explore some kinds of problems that we can solve with stacks. Starting to get unwieldy amounts of stuff. So we covered through here. So we looked at all the stack methods. We made all the stack methods for this. We worked on this in groups, and then we put it together. So we're going to hop back into a bit of analysis of stacks now that we've seen a stack-based implementation. So we said this from the beginning that we wanted everything from a stack to be constant time complexity. And the reason for this is that if we allow for worse than that, that's what a list does anyway. If we were to make this worse than the stack, we need to make some improvement on the list to call it a different structure. So forcing everything to be constant time doesn't quite allow us to do as much as the list can do. But if we can solve a problem with a stack, we can guarantee everything is done in constant time. So worst case asymptotic behavior, everything is O of 1. And of course, that's intended by the nature of a stack and what we need it to do. So what kinds of problems could we solve with a stack? We are going to dive into the concept of postfix evaluation. Has anyone heard of postfix evaluation before or know what that means or what I'm talking about? Excellent, something that's brand new to everybody. So we are used to writing math expressions the way we are used to, using standard order of operations, using parentheses to override orders of operations. And you've all seen how we write math expressions. But my question for you is, can we get rid of the parentheses? Is there a way to write math expressions such that parentheses are not necessary? And why would I ask the question? If the answer wasn't yes, there's a way to do that, that would seem like a really random question, or the answer is yeah, no, I'm just spewing weird language at you. So there is a way to do this. If we want to describe the way that we evaluate math expressions as people, the answer is we would call that infix notation. And this means that the symbol appears in the middle of the expression. So when we write something like 5 times 6, the times appears in the middle of the 5 and the 6. But what if we made that something that could move around? Why is it that we have the symbol in the middle of the 2 operands? What power would we gain if we could move that around to either before both of them or after both of them? Would that create any ambiguity? Would that create any additional problems that we would have to solve? So infix notation expressions look like A plus B, A times B. But of course, if you're a computer, you really don't like this. Imagine being a computer. You parse this token by token. So you read the A, then you read the plus, then you read the B. What does that system look like? You have to have read everything before you know what you're doing. you have to have looked for parentheses to figure out, is there an override to the order of expression, the order of operations that I'm used to evaluating? What happens if you get a sub-expression, meaning that before we even get to that plus, we start another new expression? A plus the quantity, A plus B. What does that mean? That means that we need to evaluate the A plus B in parentheses before we add it to the A that is on the outside. So it's a very difficult process to navigate from a computer's perspective. There are a lot of rules that you would need to figure out to code an expression evaluator. On the other hand, postfix is a way of writing expressions where the symbol appears after both. So the operator appears after both operands. So we would see something like A, B plus. And the plus signifies add the last two things that I just saw. Or the last two evaluations of some sub-expression. We could do something like this, 8, 6 plus 10 times. Anyone have a guess as to the interpretation of what 8, 6 plus 10 times evaluates to and how you get there?
Be 140.
It is 140. How do we get there?
You use 8 plus 6 and then you multiply 14 by 10.
Yeah. Note how order of operations is not really relevant here. How would you order an expression where if it was something like 8 plus 6 times 10 with no parentheses? You would write that a little bit differently in terms of a postfix expression. But the fact that the 8, 6 plus is there says that the plus has priority over the multiplication. So order of operations just kind of goes away. There are now distinct ways to write different expressions with those associated intended orders. There's no ambiguity that needs to be resolved or that we need additional rules for. When you start to really look at postfix notation and analyze it and then take a step back, you'll wonder why we were ever taught infix notation in the first place. It is so much simpler and easier to just look at and understand that the only reason infix is used is because historically that's what we've done. The same reason why we use a QWERTY keyboard and not a Dvorak keyboard or something more intelligent. So equivalent of an expression that looks like the quantity 8 plus 6 times 10. And now we need those parentheses in there because they override the standard order of operations without parentheses. So we made an equivalent expression in postfix that didn't require those parentheses. Let's do some more examples. What's the answer? I've given you enough information for this to not be ambiguous. Sorry? 24. 24? That would be a good guess. Because it's right. So the plus refers to the two things that come before it. When you evaluate this, it's not 24. 3 plus 4 is 7. And then when you evaluate the 2 and the 7 and the times, you get 14. So we can think of this kind of like how we've thought about a stack, because a stack is exactly how this is going to get evaluated. You can imagine that there is a stack here keeping track of everything that we have seen so far. When we see a number, you're just going to push the number onto the stack. So we see a 2, 2 goes on the stack. We see a 3, the 3 goes on the stack. We see a 4 goes on the stack. We come to this plus, and it tells us add the top two elements on the stack. So we're going to pop, evaluate, push. And now is where we need some order of operation to this, because as soon as we see subtraction or division, they're not commutative, which means we can't change the order and evaluate to the same thing. So the first element from the stack pops into the second position in an infix expression, and the second element pops into the first position. So you're gonna get 3 plus 4 as the equivalent infix expression to what this plus is asking us to do. So if we see subtraction or division, the top element of the stack pops into the rightmost position, and the second element pops into the leftmost position. So if you see subtraction or division, that's what's going on there. So this evaluates, and what ends up happening is we popped, we evaluate, and we push. So the resulting stack after this is a 2 and a 7. We popped the 3 and the 4, we evaluated a 7, and we pushed the result back on the stack. Then we go to the times, and that tells us to pop the top two elements of the stack. The top one goes in the rightmost position, the bottom one goes in the leftmost position, and you get 2 times 7, which pushes the resulting 14 on the stack. And then once you are done evaluating a postfix expression, the answer is the top element and should be the only element on the stack. Questions on the logic or how that was calculated? Okay, let's try some more examples. 2 4 times, 3 5 times plus. What do we get?
23,
23?
I think.
Other people get 23, other people get something else? 21 versus 23.
Yeah.
I agree. The answer to this is 23. How do we get there? Somebody who got 23, what's your thought process? Yeah?
So I did like the 3 times 5 first, and I got like 15. And then I added the 8. Well, I just multiplied the 2 times 4 and 3 times 15.
Yeah. Yeah, so we have 2 sequential tasks to do. We can see that this and this are kind of independent of each other because of how they are set up. But in general, you don't ever have to look backwards if you're parsing something that is postfix. You only ever have to continue to look forwards. The answer that you need is never more than 2 deep in the stack. If you're going to evaluate something, pop, that's all you need. You never need something that's deeper in the expression than that. So even though this 8 is going in there, since there are 2 numbers followed by a symbol, that's basically the equivalent of putting that in parentheses, saying evaluate that first and store this for later, because both of these answers are needed for the plus that we do afterwards. So this becomes element 1, element 2 of this operation, 1 and 2 of this operation, and then 1 and 2 of this operation. But those answers are stored in the stack. So 2 4 times evaluates to 8. 3 5 times evaluates to 15, and then you take 8 15 plus to get 23.
Did it take up too much time if you did the stack?
Do the stack one, I can do that. We're going to start with 2 on the stack. See the 2, push a 2. See a 4, push a 4. See a times, pop, evaluate. So this pops here, this pops here. We get 2 times 4. So the result of that is going to push the 8 onto the stack. Then we read the 3, push a 3. Read a 5, push a 5. See the times? Pop. Pop. Evaluate. Pop. Pop. Evaluate.
So if we're trying to create a program for this, we're not putting everything into the stack all at once, we're doing.
Right, there's conditional logic depending on what you see. If you see a number, push it on the stack. If you see an operator, there should be at least 2 elements on the stack already. If there are not, you have a syntax error on your postfix expression.
All right, thank you.
Yeah, does that make sense? Any questions on the stack-based work? All right. 2, 3 minus 4 plus 5, 6, 7 times plus times. Evaluate. Yeah.
Or negative, or is that just a subtraction?
That is a subtraction sign.
When you get past the addition, you. What are you, oh gosh, I need to draw this out.
It is amazing how frequently drawing things out helps.
Free, hang on. I think. Yeah, drawing it helps a lot. Is it always? When you do something at the end, is it always like the first 2 elements?
It's always the top 2 elements of the stack.
The top 2 elements of the stack? Oh,
Yes, you always start at the left, you always go to the right, and whenever you see a symbol, there should be 2 elements waiting for you on the stack. Oh man, how do I choose? You all look so excited.
it's very strong, I think.
We're gonna have to do a 3-way rock, paper, scissors. No, there's no time for that. I'm just gonna have to choose.
First game of Commander.
Yeah, right, there you go. Haven't heard from Jake yet today.
I got 141.
141.
I got 141 too.
Is that 141 as well, or 1,400?
One as well.
Have to be sure. So we see the 2, 3 minus. What do we do with that? Is that 2 minus 3 or 3 minus 2? Is that very much changes what we do with,
3.
it is 2 minus 3. So if we're making a stack, we put the 2 on the stack, we put the 3 on the stack. When we pop the 3, it goes into the second position. When we pop the 2, it goes into the first position. So we get 2 minus 3, which evaluates to -1. So this, I'm just gonna draw this out. This evaluates to -1. And now when we have -1, 4 plus, that evaluates to 3. So I'm just kind of gonna draw this out and say the result of everything up to here is 3. So then we have 3, 5, 6, 7 all on the stack at the same time, because when we see numbers, we just pile them on top of each other like that. So this times is going to operate on the 6 and the 7. So that's gonna give us 42. The plus is gonna take the last two elements on the stack, the 5 and the 42. So that's gonna give us 47. And then this times drops down and it's gonna evaluate 3 times 47. You can't do that in your head, practice. Yeah, the way I drew that out is a little challenging. It's kind of I'm trying some different ways in case people see this problem a little bit differently. So instead of drawing it out like a stack, I'm kind of trying to use a visual representation of building up an area and where the solutions would be. Anyone see this differently? Anyone have a different way of breaking this problem down and understanding the solution?
I don't know how I got to the answer.
So -1
I feel like I got that first part right in my
plus
answer.
4. So this evaluates all of that portion, and then we build this portion out. Starting at the innermost and working out. But again, if you're doing this as a stack, you can just read this left to right. There's no middle working out like we have in infix, which is why when I'm solving this way, you can see exactly what you would need to turn this into an infix expression. In fact, let's try that out. Write this as an infix expression. What does it look like? That minimizes the parentheses.
Do you dock us on a test if we did go crazy with the parentheses?
As long as it is correct, I would at least call it most correct.
I just hate when it's like it's subtractions and additions to the next stage. of it.
Yeah.
Put parentheses.
Yeah, if it's the same order of operations, we can read them left to right, but yeah, more parentheses than that doesn't change how you evaluate it. So that's kind of nasty to even think about. I mean, when you see this, where do you start with it? You have to do an entire analysis step of how am I going to evaluate this? Let's evaluate this sub-expression, let's evaluate this sub-expression, and then let's multiply it together. If you break it down into postfix with a single pass left to right and a stack, you're done. You don't have to question, where do I start? And from a computer's perspective, where do I start is usually a lot of logic. So with postfix, you always start in the same place, far left, and using a couple of rules, either push to or pop from and evaluate your expression. I accidentally did all this thinking about the stack anyway. So coming up with the algorithm, this is kind of some pseudocode for a postfix evaluation. So for each character, read the character. If you can interpret it as a digit, convert it to an integer and push it onto the stack. If the character that you read is an operator, meaning it's a symbol, then we want to pop the stack twice to give you the 2 operands, perform the operation, and push the result. When you're done with the entire expression, the answer is on top of the stack. Postfix evaluation is the easier of 2 things that I will be having you do on the next homework assignment. The more challenging one is to take an infix expression and convert it into a postfix expression. Nothing convinces you that infix is a terrible idea, like implementing infix to postfix conversion. So you can imagine that now, as a computer, you're trying to interface with a human. And this human annoyingly doesn't know or understand postfix. All they can write and type is infix. So what you want to do is take their gobbledygook infix and turn it into a lovely postfix expression for easy evaluation. Because from your perspective, the computer, that user is weird, and you need to convert what they report to you into something that you can understand. So let's take a moment and see if you can talk this out. You're going to write a program that's going to take in a string, and that string is a long sequence of symbols or tokens. And each of those tokens can be thought of as either a number or a symbol. If it's a number, we kind of know what to do with it, but if it's a symbol, now what happens? How do you deal with these parentheses things that this end user wants to do? How do we read in parentheses? How do we read in other operations? How do we account for this weird concept of order of operations? And how do we convert all of that into the answer? You're not trying to evaluate this infix expression, you're trying to just convert it into a legal postfix string with the same answer as that infix expression. So talk this out in groups. I think this is more than one person activity. Put your brains together, hopefully not physically.
You want to scan.
Yeah.
We aren't rams.
Yeah. Yeah.
Runtime errors.
Right, exactly.
And, yeah, I was like, parentheses, exclamation. So,
Also.
yes, okay, so the way I thought of it is we need to get the in like $10 like parentheses have a higher value.
Okay, that's the smallest number. When is there another patient?
Right.
So that you do your static research. We're creating a stack.
Yeah. So just kind of break up. I was going to find the small.
Like how it works.
Actually, one of my songs is coming.
And then we.
We go through.
We're different.
I don't think it's Yeah. Well, just headed out, yeah, just trying to get this pseudo valve.
Yeah.
Yeah. Yeah, maybe for this. One of it is. Two, right?
So you don't build this first.
This is these two. And then this. Plus. Yeah, and so. Yeah.
This goes first, this whole section.
Yeah.
We know some of this.
Why have it versus that?
So, yeah.
Yeah. And then it has to be tricky with both of them, you have that operating six. And that's the most in between.
My scenario, so you go to this.
You know, especially.
I don't know how to do it.
Yeah. Like you can't. Like you can even only like one step. Yeah. We hit some, we hit a non. Yeah.
I guess what were you?
It's just taking the last two. And this turns into two. That turns into. 42 and get.
So I'm starting to just one scale.
You also do have. Can we can't still on this? Let's be. That's right. So, yeah, it's just figuring out how to. Because that is illegal. The rest of them, I think that's forget. Because you go through this. It's like
Which I think that's the. But I don't think there's a way to like get rid of it.
Right, so maybe like sorting the symbols. Right.
Meaning postfix doesn't necessarily.
And so.
Doesn't necessarily.
Right. Yeah, so, well, so we.
I don't know.
No, that doesn't make sense, but it was. We see that in reverse instead, is it?
Yeah.
So you probably had basically sorting, while there's.
Yeah, so I'm saying it.
Go through. When you check. Number.
Like.
Okay, that's okay. Number. Add this.
And the B.
Go through. Symbol. Oh.
I think it might have to, it might have to.
Symbol.
So what we sort of.
In this case, the equivalent.
I see, yes, because the five.
Right.
Yeah.
So I don't know if that's like.
Yeah.
Going forward, the rest, like.
And now it's not, it's full. Well, so it's, because he was like, yeah, I would have plus first and then.
Multiplication has a higher.
So you'd have to do three, you'd have to do. Okay, numbers.
Well,
Well, it did.
You would, yeah, it's
Go back, parentheses.
It's really annoying because you actually have to.
Yeah, I agree.
Or you could actually.
Yeah.
Go back and choose.
I still. You can't add or exclude.
To have to just keep going back.
Oh.
Check.
There's.
Generally,
I want to check in with people. How's this going? Do we have some ideas? Have we figured out that we can do this in a single pass left to right? That's my hint to you. We can do this in a single pass left to right. What did we do last time that we used a single pass left to right? We used a stack of some kind. This is in the middle of a slide deck about stacks. How can we use a stack in a single pass to do this? Yeah.
Oh, I'm not raising my hand, it's just like.
This is the plus, if we push the plus line.
Reevaluate, keep thinking,
Yeah.
and see if you can come up with something.
Yeah, we can push the ball.
Yes.
Yeah. So. We pop it, so number 7.
So this is, it's not.
How would you do it without doing something like that?
It's a numbers thing, it's not.
Well, just make us. But like attack from what object? It's just. Yeah. Okay. You make it. I think maybe we need to. As all, okay, everything will be. So. And we have to do it in one pass. So. I think we have to have it understood. Like, you can't really expect something else around you. So you get the parentheses. It's never gonna know about this. Hit the parentheses, we pop. Store. Inside, we go, within 7. Within a multiplication. No. 6. With the parentheses. Those are 2 numbers. Oh, we did it. It's a sign.
And she's still using quicksand.
It's a sign. We know the number sign, we know the name. You know, like one.
That's nice.
Yeah,
Public example, so excited.
when we disarm. Office and then we put in stuff. Yeah. So we need to start out here. Oh, because we start on top of this stack, so we hit the 3. Yeah, but again, it's doing. And instead of diving, it says 7. Put 7 on the stack. Then we need to put. But this is actually this is what we want. Yeah, this is what we want. So we get here, and then we hop in. I mean, you're not. Does it work with? Yeah, we put the 3 in the end. Put the 3 in. Like, yeah, you know, it's fine. It's fine. So right here, so you go, it's the 7. It's the 7. Yeah, it's the time. So I'll show you this. Yeah, see, that wouldn't work. This is different. Yeah, I'm set. So that only works. They have to do something special. We did for right now. Yep, so we start here. I know that this operation is. Right, but couldn't you just. Instead, so maybe do the right side of the string, so you can still rewrite that. So we go like, in parentheses, we go 7, and then make that. Yeah. Here. We hit a parentheses, we go, okay. That's true. Yeah, that's right. Okay. Well, I know we go 2 strings to the actually.
Yeah.
Yeah.
I think we can use one.
So it hits the 3, it shows the 3 on that.
Any progress? What are we thinking about?
It's parentheses. Yeah, right, then we'd have to make a different conditions, so we did.
Who's still making progress? Who wants more time to work on it? Close.
Yeah. I think so. Okay, so it hits the second.
I'll give you a couple more minutes.
That works. Wait, no, that doesn't. Because it does 3 and then plus, it needs like. We have to. Yeah, because it does this. So we wanted to do. Like, we used to have done something. We wanted to do this operation. And then it would be.
You read a rental.
I want to write that. And that's 3 plus 7, 6. And now we don't have the same.
Instead of reading it left to right.
And it's like big whatever. We have to, yeah. First that was, yes.
Is there a category? We need to see.
This is, I don't know how we do that, but we go. So we don't put our plus on. Maybe that helps my instead, so we don't have to see. Yeah, we freeze everything now, we do 7 on that. I think we have to, like, no, you could put 7 on the same stack. And then say 5, and then it's sometimes it's also it'll do. It'll put 3, 7, 6, 7 first. Yeah, we'll do 6 times 7, and then it'll do that. How do you code? I don't know, but that's impossible.
Has anyone stumbled upon the moment of genius? What goes on the stack? I've never had one of those.
I haven't.
So when we were doing our postfix evaluation, what went on the stack were all of the numbers, and when we saw symbols, that told us what to do with the numbers. What goes on the stack when we are trying to convert between infix and postfix?
Symbols.
It's the exact opposite. We want symbols on the stack. Whenever we run across a number, if we notice, whenever we're doing an infix expression and a postfix expression, the numbers are in the same order. Nothing changes about the order of the numbers, which means our first rule is when we see a number, output it. The only thing that may get delayed are the symbols. So if we only store symbols on the stack, do we want to store parentheses? Is there any way for us to just skip over the parentheses, or are they giving us some kind of useful information? It turns out it's very useful information. So we do need to consider putting left parentheses at least on the stack. And then seeing a right parentheses will trigger something with regards to what's on the stack. Let's take a look at the algorithm. It's surprisingly simple. Read everything symbol by symbol. If it's a number, which we're gonna call an operand, you just straight up output it. You're done with it. No need to consider any history. If it is a left parentheses, immediately push it on the stack and move to the next symbol. If it's a right parentheses, we need to pair it with the topmost left parentheses. And that means that you're going to start outputting symbols, everything that's on the stack, you start outputting until you reach that left parentheses. If you see some other operator that is not parentheses, okay, parentheses aren't an operator, but any other operator, you now need to consider order of operations. And here's where the order of operation rules come in. You will pop all symbols off the stack as long as each symbol that you reach is either higher or equal precedence to the operator that you just saw. So let's say you see a plus, and what's on top of the stack is times plus something else. When you see this plus, you're going to pop the times, higher precedence, you output it. Pop the times, higher precedence, you output it. Pop the plus, higher precedence, you output it. And then once you're done with this process and you see something that is either lower precedence or you've emptied the stack, then you're going to push the new symbol that you just saw onto the stack. So stop before popping a lower precedence operator or a left parentheses. If there's a left parentheses, you also want to stop. But once you are done with that process, then you push the new operator that you just saw onto the stack. So there's an emptying procedure followed by putting one new thing on the stack, and that's the entire algorithm. Here's an example. We're going to parse A divided by parentheses B plus D minus D. I think there's just enough time to go over this. So we have an empty stack. We see the A, it is immediately an operand, so we're going to output it. So the output is immediately an A. We then see a divide. Since this is a symbol, we're going to look at the stack. Since the stack is empty, there's nothing to output from the stack, so we're going to do nothing and then push on the divides. We see the left parentheses, and that tells us just push it on the stack. Doesn't matter what's already on the stack. We're going to push the left parentheses onto the stack. We next see the B. That's an operand. It immediately gets output. Next is a plus. When we see a plus, we're going to output all higher or equal order operators that are on top of the stack until we reach something that is lower order or left parentheses or the stack is empty. Let's say left parentheses is immediately on top of the stack. There's nothing to output. We put the plus on the stack. We see a C. That's an operand. We're going to output it. We see the right parentheses. Now, when we see that, we're going to pop off all operators until we see that left parentheses. We will also pop off, matching it with that right parentheses, but stopping there. So we're going to output the plus. Oh, look, there's the left parentheses that we're going to match with it. So we pop off the left parentheses, but then we stop. So we output, we now have ABC plus, still with divides on the stack. We move along, we see the minus here. So we're going to do pop everything off the stack that is higher precedence or the same precedence. Divides is higher precedence than minus. So we're going to pop it and output it. Now we have an empty stack. So we complete this operation by putting the minus on the stack. Then we see a D, that's an operand, we output it. Then we see the end of file. So when we see the end of file, we pop all remaining operators from the stack and put them in the output. So since the only thing that was left on the stack was a minus, we pop off that and append it to the end. And what we have is a postfix expression for that infix expression with just a few rules. So the question I have for people is, if you overcomplicated this, why did you overcomplicate it? What about your thought process had you doing something that was more complicated than this? And again, that's not to say that your thought process was wrong, but I think that this creates a wonderful opportunity for you to kind of see the difference between how it is that your thought process tackles a problem like this, and then you look at an elegant solution. And there's something to learn about optimizing that thought process. So that's gonna be different for every person in here. Every time I see this algorithm after having not seen it for a while, I kind of appreciate just how simple it is and how easy it is to overcomplicate. What do we think? We'll end the class with a show of thumbs. How do we feel about both post-fix evaluation and in-fix to post-fix conversion? We see some pretty mid results here. So I'm gonna draw this out with a stack at the start of the next class. I think that's where we'll start with that, just so we can better visualize it. We'll go from there.
Yeah, no, you had it.
Office hours starting now.
You had it too. Right. You said it.